Hi class, for this quick video we're going to talk about inscribed angles and subtending those angles within a circle. I guess what we need to start off with is just a circle. So there's my circle. And then what I'm going to do is I'm going to create an inscribed angle, and by doing that I'm going to have 1 point here and 1 point here and another point there. And an inscribed angle, all that is it's a bunch of chords that are sitting inside a circle, and well, turns out that there's some information that you can glean from this, which I think is pretty interesting stuff. Mostly what we're interested in is being able to move this around and seeing what happens with the angle measurement right in here as we look at also the arc over here. Okay, so let's find the measurement of just that angle right there. So measure angle. Okay. So we got 41.6 degrees. And then the other thing I'm interested in is I want to find out about that arc measure here too. So I'm going to find the arc angle, and that's just from E to G. And the cool thing is that as this moves around, as point F slides anywhere along this circle, the angle stays exactly the same. And what I think is really cool is as I move E, let's say we get to a nice round number like about 70. It turns out that this measurement of the arc angle is exactly twice as the measurement of the angle over here of the inscribed arc. In other words, angle F subtends this length over here, and it's twice of what you see right in angle F. And we can use a whole bunch of different applications. One thing that we could do here, let's add a dot up here, and then let's have a line running through these two dots. So we're going to construct a line, bam, straight through. And then what I'm going to do is I'm going to add a dot down here and see what I get if I move point E all the way over to that point right there, and then if I move point G all the way over. Now before we go there, let's guess. If the arc angle is 180 degrees, what is measure EFG going to turn into? 180, I'm willing to bet that it's going to be about 90. And there we are, we're at 89.91 and 79.81. And does it matter if the circle changes or gets larger? It shouldn't have anything to do with that. In fact, we could get real big here. Things are still locked in. And as we change the size of the circle, it still is exactly the same. So, bottom line, here's your theorem right there.